Welcome back for representing nonlinear relationships, or sorry, non-proportional linear relationships. This time we're talking about representing linear relationships using graphs. A linear equation is an equation whose solutions are ordered pairs that form a line when graphed on the coordinate plane. Linear equations can be written in the form of y equals mx plus b when b is not 0. The relationship between x and y is non-proportional. And you'll remember that b, that is your y-intercept. So when you have a graph where the line crosses that x or the y-axis, that is your y-intercept or your b. And so if b is 0, then it would be here, and that would be a proportional relationship. Non-proportional, however, would be anywhere but the origin. Okay? So we have an example here. The diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth of 2/5 of an inch per year. Therefore, the equation y equals 2/5 x, for x standing for the number of years, plus 10 gives the y the diameter of the tree in inches after x number of years. Draw a graph of the equation and describe the relationship. So what they have, they started with 10 inches because that's where they're starting. That's the initial measurement. And so that's where this 10 comes from. And then every year after that, it's expected to grow by 2/5 of an inch per year. And so that's where this came from. And then they took a table and they put in the number of years. So they estimated the very first year, the initial year, was at 10. So at 0 years growth, it was 10 inches. After 10 additional years, they measured and it was 14 inches. After 20 years, they measured the diameter and it was 18 inches. And after 30 years, they measured it and it was 22 inches in diameter. And then at 50 years, they measured and should be 50, or 30. Sorry, 30. Plot the ordered pairs from the table and then draw a line connecting the points to represent the possible solutions. And they've done that for you. We're going to take a look at this graph here. So they have taken these points that were in the table at 0, 10, and so it starts about there. There's our y-intercept. Then 10 and 14, 20 and 18. They came across the 20, went up to where 18 is. And then they drew a line through those points. And so they were able to determine by using these points, it is linear. However, it is non-proportional because it's not passing through the origin. Okay? Let's try this your turn. They want us to make a table and graph the solutions of this equation. They gave us the values for x that they want us to use and to determine what the y is going to be. So in our first one, x is -1. So we're going to replace the x with -1 and add 1 to it. So -2 times -1 is 2. 2 plus 1 is 3. So y equals 3. At 0, -2 times 0 is 0. 0 plus 1 is 1. If I replace it with x, y is going to be -1. And if x is 2, y is going to equal -3. Now we're going to take these ordered pairs and then we're going to plot them. So at -1, 3. So at -1, 3. At 0, 1. At 1, -1. And at 2, -3. And then we're going to go ahead and draw a line through it. See if I can get them the first time around. Okay, so is this proportional or non-proportional? Okay, if you said non-proportional, you're correct because the line does not pass through the origin. Okay? All right, if you have any questions, please let me know. Thank you.